Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the next topic of the Unit C, Grade 11 Chemistry, which is the strength of acids and bases. So we're doing the strong acids, weak acids, and strong bases and the weak bases in this lesson. So basically, this is all the strength of that. So what are the strong acids? You know, this is the top sets on your acids table are your strong acids, and after they are all the weak acids. So strong acid react chemically, which is more than 90%, 99% reaction can be occurred with water to produce the hydronium ions. They react with water and produce the hydronium ions. The high concentration of the hydronium ions results in the strong acid properties and the low pH. If you have a strong acid properties of that, when we have a higher concentration of hydronium ion, we have a low pH in that case, which is the more acidic pH. We have to mention the major entities in this, which is a species list we called, and they must be present in the water. Water must be present in that list. Strong acids are HCl, HI, HBr, HNO3, H2SO4, HClO4, and HClO3. They are all listed in the data booklet, and they are the top sets, which are all the strong acids. The single rational arrow used in the chemical reaction equations, because this is strong acid, that's why we use the straight arrow, like the one single directional arrow. And we can use this too. We write this too, like greater than 99%, less than 99%. So we can use this too to measure that this is the strong acid reaction. So then we have a weak acids. Weak acids, which are react completely with water, incompletely with water, less than 50% to produce a relatively few hydronium ions. They produce relatively few hydronium ions and have a like less than 50%. Relatively low concentration of hydronium ions result in the weaker acid properties, and we have a pH which is more closer to the 7, like we have 5 sets pH of that thing. Major entities we have to present, and in that the major entities are also the reactants too. The major entity present in this are the reactants. So we have to write the species, we have to write the reactants as a species list in that. Equilibrium arrow we have to use. Equilibrium arrow is this. You can use this signs like less than 50%, less than 50% or greater than 1% written above the arrow. So that this is optional thing, but this is the weak acid after top sets in acids table. So we have example over there. We have HNO3. So HNO3 is a strong acid. So HNO3, which is aqueous, we can write this with water, liquid, this arrow, and we get H3O plus aqueous, and we get NO3 negative aqueous. So what are the species? So we have to mention the species list. We have a water, then we have NO3 negative aqueous, we have a H3O hydronium ion. This is the species list for this. Now we have HF. HF is a weak acid. So if it is a weak acid, this is react with the water. Now we have to use the equilibrium arrows, and they are F minus aqueous plus H3O plus aqueous. Done. But in their species list, if you write the species list for this, we have to include the water and the reactant, which is HF. We can't like put the products in that, because in the weak acid we have to have a major entities present in the solution are the reactants we have, and with water, acid and bases too. So the bases kind of work same as the acids. So how can they work? We have a strong basis first. So strong basis deassociates. In bases we basically do the deassociate thing and completely water to produce hydrogen ions. Results in a solution with the strong basic properties, and they have a high pH, about like 13-14 pH. All ionic hydroxides of groups 1 and 2 except the barium are the strong bases. So you have a group 1 and group 2 in your periodic table, all have the strong bases except the barium. Barium is not a strong base. And the oxides from group 1 and 2 except the barium are the strong bases because they react with water to produce an ionic hydroxide. They react with the water to produce an ionic hydroxide. That's why they are all the strong bases, and they are the oxides too. They are the strong bases. That's why we use the single directional arrow. And their major entities, which are the species list present in water, will be the products and the water. Like this, rest with this, you produce this. We already did this reaction in the previous lesson. And this with this to produce this. So this is the major thing you have to know in the modifiers theory. We already discussed that thing in that topic. Next, we have a weak acids, same as the weak acids. So the weak bases are reacts with DSO partially, which is greater than 50%, with water to produce relatively the few hydroxide ions. Again, they have a weak basic properties and pH is closer to the 7, which is 8, 9. And most bases other than those listed above are weak bases. The things which are not listed over there, all are the more like they have a weak basis. Equilibrium arrow we have to use because of the weak, and after that, the major antiprice in water will be the reactants. So same as weak acids as we did in that thing. So let's do a question. So the question says the solid sodium acetate is dissolved in water. The final solution tested and found to have a pH of 8. So that means we have a base. Write the balanced chemical equations to show the reactions and explain this evidence. So basically we have a sodium which is Na plus. So Na plus, and acetate is the polyatomic, which is like CH3COO negative. So basically we have a NaCH3COO solid. We have to deassociate this first. So to deassociate this first, you get Na plus aqueous plus CH3COO negative aqueous. In this, we have to get rid of the negative sign to get the H, which is hydrogen, because this is a base. We have a base, and this is a strong base basically, because we have a sodium. This is a base. Then you have to take this as the front, which is the aqueous. It reacts with water. In the second term, now sodium is gone, so you have to use this thing. Done. So you get CH3COH plus OH negative aqueous. And what's in the species list? So basically you have a Na plus aqueous, you have CH3COO negative aqueous, and the water. All the products from the first reaction, because this is strong base. Basically the strong base, after that you take this equivalent, because CH3CO negative is not a strong base, it's weak base. With this base, the species goes like this. That's all for this. The limits where EduVibe learns more not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till see you with EduVibe.